assignment, problem solving, itong page 422, practice exercise 18.1. We will answer that together. Get your textbook, pen, notebook, and scientific calculator. Before we will proceed to our next topic, let's have a quick review. Okay, what is the difference between work and heat? Can still remember, just type it in our public chat box. If you want to answer, then you click the raise hand button. Who can still remember the difference between work and heat? Mm-hmm. Anyone? Okay, heat is defined as the energy in transit, while work is defined as the product of force and displacement. Okay, correct. What is the formula to solve for heat? Formula to solve for heat. What is the equation? Okay. What is the symbol of heat, by the way? Symbol of heat. You include the symbol of heat. Q is equal to MC delta T. Okay, correct. Capital Q, ha? Okay, next. What about the specific heat symbol? What is the symbol of specific heat? C. And the unit of measurement as a unit of specific heat. C. Joules per kilogram Kelvin. And the other one, that's the standard unit. How about for katong cal? Cal per grams degrees Celsius. Okay, correct. Okay, what is the symbol for mechanical equivalent of heat? Mechanical equivalent of heat? Is it W? That is work done. Mechanical equivalent. Okay, capital J. What is the constant value of mechanical equivalent of heat? 4.19. What is the unit? Joules per cal. Okay, correct. All right. So let's proceed to our practice exercise 18.1 on page 422. Naka-answer mo wala? Let me ask you. Na may answer? Wala. Wala. Ang mga nawong. Okay, for those na nag-answer, what is your final answer? Just type it in our public chat box. 219 point na ako answer. Pariyara na sa walay answer, Lawrence. Okay, only Miles? Isa, 219.98. How about the others? Duwa lang? Ay mo kadlok, uy. Wala man gyapon check sa ilaha, oh. 219.9. 219.98. Nanguban kay copy-paste. Hmm. Okay, wala na. Wala na yung new entry. Sige, let's answer. Can they read Nor? Nor Hasmeda? Nor? Nangi pa siguro si Nor. Gab, can they read the problem? Okay na, Nor?
Uh, I want to answer.
Yes, Gab.
A 52 grams aluminum calorimeter contains 175 grams of water at 25 degrees Celsius. We continuously stir the water and found out the temperature of the water has risen to 25.3 degrees Celsius. How many joules of work did you do in stirring the water? Neglect the heat absorbed by the stirrer.
Okay, so let's find the given. Sige, you mentioned one be, given in this problem. Sige, cite the given. What is 52 grams? Mass of what? Duha man na ka mass. Okay, mass of aluminum is equal to 52 grams. And then, mass of water, okay, 175 grams. Gi-add nimo ang masses. Sige lang. Okay ra, okay ra. Okay, another given. Aside from the masses of aluminum and water. Okay, T final. What is T final here? And T initial. Asa diri ang T initial? Temperature initial. Okay, final is 25.3 degrees Celsius and then the initial temperature is 25 degrees Celsius. Okay. Since you are asked to solve for work, sa gali ang formula to solve for work. 'Di ba? Work is equal to mechanical equivalent J times heat, Q, right? But then, wala pa man tayo value of heat, Q here. So, we need to solve for the heat of aluminum and heat of water. Saan galing pag-solve sa heat? 'Di ba? MC, delta T. Sure, wala may specific heat C. Like what I said yesterday, specific heat are constant. So, pwede rin na siya ma-search sa Google. Okay, na list of values for the specific heat of a certain object or substance. Sige, search daw sa Google. Specific heat of aluminum. What is the value? Gamita tong calorie per gram degree Celsius. Kay ang given man is in grams and then the temperature here is in degrees Celsius. Sige. What's the value of the specific heat of aluminum?
0.9
Unsa na siya? Joules per kilogram Kelvin? Sa asa na siya?
joules kilogram.
Katong kuan, cal per gram degree Celsius. Zero point 0.214. Kasi nakakita og 0.22. Ang ako ra bang gigamit is 0.22. 0.214 gyud din yung nakita. Sige, we'll just use na lang 0.22 para uniform ta. Anyway, ang next na digit raman ang naka-differ. 0.22 instead of 0.214. So that is the specific heat of aluminum. Kindly type, Pauline, specific heat of aluminum is equal to 0.22 cal per grams degree Celsius. What about for water? What is the specific heat of water? Sa inyong na-search. Okay, 1.00 or 1 calorie per grams degree Celsius. Okay. Now, you solve na for the heat, both for water and aluminum, since you know naman the specific heat. Okay? By the way, what is the change in temperature? You just subtract the final and initial temperature. Sige, delta T is equal to Minus lang, 25.3 minus 25. Okay, 0.3 degrees Celsius. So that will be our delta T. Sige, solve na for the heat of aluminum and water. Then, pag makuha na ninyo, i-add din sila together. Sige, you try before I will write the answer in your screen. What is that, Miles, for?
Ay ako gi-solve sure ang heat.
Sa aluminum or water? Or kuha na siya? Gi-add na nimo.
Di-add.
Pila imong values sa aluminum for heat? 3 point. Like imong answer? Sige, ako sa i-write ang mga given. You try ha. Kasi nag-Facebook ra mo dira. Tawagon gyud ta mo ron. So mass of aluminum 52 grams. Mass of water or H2O 175. The specific heat of aluminum is 0.22 cal grams degree Celsius. Specific heat of water is 1.00 or 1 cal per grams degree Celsius. Then our change of temperature, that is TF minus TI. TF is 25.3 degrees Celsius minus 25 degrees Celsius. So the answer is 0.3 degrees Celsius. That will be our change in temperature. So you are required to solve for work done. Okay. What is the solution? You just add heat of aluminum and water and then multiply it to mechanical equivalent of heat. So this is now the equation. J times Q, J Q heat of aluminum plus the heat of water. To solve for the heat of aluminum, so dire na ako i-write. You use MC delta T. Okay? So M is 52 grams for aluminum. And then specific heat of aluminum is 0.22 cal grams degree Celsius. And then our delta T is 0.3. Okay, so you can now have the value of Q or heat of aluminum. And then heat of water, you use also MC delta T. Mass of water is 175. Then the specific heat is 1 cal grams degree Celsius. And then change of temperature 0.3. What is your answer for heat of aluminum? Sige, use your mic, please. Para dili na ako mag-exit. Multiply 52, 0.22, and 0.3. What's your answer?
3.432 cal
3.42. 43? 42.
432 ako.
Okay. Kuan up to 2 decimal places lang. So, 3.43 calories. Sure nga nung cal, you can cancel out grams and degrees Celsius. So, the remaining unit is calorie. So, 3.43 cal. What about for water? 175 times 1 times 0.3 heat of water. Multiply 175 times 1 times 0.3.
52. 52.5.
Okay, 52.5 calories. Okay, them. Kay gi-steer man nimo siya, di ba? Ang water, so nasagol na siya. You're applying work to the water, which increases the temperature. So 3.43 plus 52.5.
55.93.
Okay, 55.93 calories. Okay, so gamito na nato na siya here to solve for work. What is the value of J galing? Mechanical
4.19.
equivalent. Okay, 4.19 joule per cal times our answer, 55.93 cal. Sige, what is now our final answer for work?
234.35.
Okay, correct. So our final answer, hopefully maklaro ra siya. 234.35. 0.35 na ha. 0.35. What is the unit of work? Remaining unit here?
Joules.
Okay, joules. You can cancel out man calories. Okay, so final answer is 234.35 joules. Question? Hello? Okay, kindly screenshot. I-take a screenshot para mastadian ninyo. Sure, wala na question? So we added the heat of aluminum and water before we multiplied it to the mechanical equivalent J. Okay, so let's proceed. We're done with the practice exercise 18.1. Let's proceed to our new topic for this afternoon. By the way, the learning objective is to explain how heat transfer and energy transformation make heat engines work, and then illustrate the parts of a heat engine. Okay, so this will be the lesson under 18.1, and it's about heat engines. Go to page 422 of your science textbook. Okay. Since we talk about heat, you must know what branch of science that deals with the study of heat, and that is thermodynamics. Okay, so thermodynamics it came from Greek word therme, which means to say heat, and dynamicus, which means to say force, power, or motion. Okay. So thermodynamics is the study of the relations between heat, work, temperature, and energy. So it literally means the movement of heat, okay, study of heat and its transformation to other forms of energy. Okay, so that is thermodynamics. So since our topic is about heat engine, let us understand what is heat engine. So heat engine is a device that converts heat energy to work. Okay? So what are examples of heat engine? Car engines like the gasoline, diesel, petrol engines. And we have also steam engines. Okay, kanang sa locomotive trains. Kanang trains nga naay exhaust or smoke. Nakita mo mo ana, kapananaw mo Thomas and Friends. Sabay smoke, okay na. So before pa na siya karon ang mga trains is wala na may nana since kuha na siya maka-contribute na siya og pollution. Okay? So, this is examples or photos of engines. Okay. It typically uses the energy provided in the form of heat to do work and then exhaust the heat which cannot be used to do work. So that exhaust is the smoke coming out from the automobiles. Okay, kanang aso. Di na siya magamit, so i-release na siya. And then all heat engines make use of working substance or fluid inside them that undergoes different process. Like for example, In cars, what is the working fluid there?
Fuel.
Okay, fuel, correct. For example, diesel, gasoline. Okay, so those are the working substance or fluid. But for a steam engine, what is the working fluid for steam engine? Masa man nagikan ng steam?
Water.
Okay, very good. So the working substance for steam engine is the water. Okay. This is an example of steam locomotive trains. Okay. So the working fluid here is water. So there are two major types of heat engines. We have the internal and the external combustion engine. So unsay kalainan nila? Actually, kung asa lang mo take place ang combustion. If the combustion will take place inside the engine, then we call that internal. But if the combustion will take place outside the engine, we call that external. So what is combustion? It is a chemical process that requires oxygen to burn a material such as the fossil fuel, paper, and then wood. It also provides the production of heat and light during the process. Okay? So to fully understand what's the difference between the internal and external combustion engine, let us watch these videos. Okay, we have for external, kanang sa left side, the fluid, working fluid is the water. And the on right side, that is an example of internal combustion engine using the gasoline engine. Okay, so let us watch this video before we will answer the process questions later. Start sa ta sa external. Internal na lang ta first.
Science, please!
Do the words auto mechanics make you curious? Actually, it's a cinch. A car is made up of wheels, seats, fuzzy dice, a body, and an engine. The internal combustion engine. The engine works in 4 stages. First, a valve opens and the piston lowers, letting a mixture of fuel and air into the combustion chamber. Second, as it comes up, the piston compresses the fuel-air mixture. Third, a spark from the spark plug ignites the mixture, which pushes the piston down again. Fourth, the exhaust valve opens and as it comes up, the piston pushes the spent gases out. And the cycle starts over again. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. The movement of the engine is transmitted to the wheels for the driver's delight.
Okay, that's for the internal. So the combustion will take place inside the engine. What about for external? So let's watch.
How do steam locomotives work? With the invention of the commercial steam engine starting the Industrial Revolution, these icons of progress made travel and transportation by rail a viable option, cutting travel times and connecting communities. Here's a somewhat simplified steam locomotive. With many trains of this era, the boiler is clearly distinguishable. A steam locomotive needs water and fuel, usually coal, carrying them either on the locomotive itself or in a tender pulled behind. The fuel is used to run a fire inside the engine, burning inside what's called the firebox. The fire is managed by the fireman in the cab, who, along with the driver, is needed to run the steam locomotive. The firebox sucks air from underneath the train to keep the fire from starving. The solid fuel sits on top of grates, through which dead ash can fall down into the ash pan. The firebox allows heat and smoke to escape the chamber through the so-called fire tubes, running the length of the boiler. The boiler wraps around the firebox and fire tubes, thus heating the water inside to boiling point, creating steam. As more and more water evaporates, steam builds up inside the boiler, creating pressure. Inside the steam dome, the steam can find a way out of the boiler towards the cylinders. In case the pressure becomes too high and the boiler risks exploding, a safety valve pops to relieve pressure. The amount of steam exiting the boiler is controlled using the regulator valve. This is effectively the throttle of the steam locomotive. Because as the steam runs down to the cylinders, we get to the part that actually drives the wheels. There are two sets of cylinders, one set on each side of the train. Steam engines on steam locomotives are so-called reciprocating piston engines. Each set has one cylinder with a piston, connected to the driving rod, which in turn is connected to the driving wheel, which can be connected to the other wheels. The other cylinder contains the slide valve, which allows fresh steam to enter and used steam to exhaust from the piston cylinder. This way, the piston is pushed once from both sides to complete one rotation, creating that reciprocating motion, which is then used to rotate the drive wheel. The steam, now done with its job, exits towards the smoke box, where it joins any smoke coming off the firebox to escape out the chimney. Do you want, for instance, a more in-depth look?
Okay, that's for the external combustion engine. So if you notice, wala siya inside the piston. Okay? Ang ignition is sa gawas lang, katong sa coal and then water, okay, to produce steam. So let's go back to our PowerPoint for a while. Saan na to? Let's answer these questions. Let's start with, what are heat engines? Anyone? What are heat engines? Sige. Let me call.
System.
Wait. Mag-call na lang ko. Von, heat engine, define. Von, Vista. Namakod na. Namakod na sa
Sure.
higdanan. Okay, heat engine, define.
Nang kuhan, sir, need o kanang kainit bito or combustion, sir, para mugana ng engine. Tapos,
Device. It is a device that converts
ah,
heat. Sige.
heat
Say.
into, sir, mechanical energy.
Okay, mechanical energy or work. Okay, correct. Next. What are the two major types of heat, Janessa? Two major types of heat engine. So there are two. Sa to. Janessa, hello?
Internal or external, sir?
Okay. External and internal combustion engine. Okay, next. How are external and internal combustion engine different from each other? So what's the difference between external and internal, Candy? Candy, hello? Say kalainan ni internal and external. Candy? From the word in and ex, combustion will take place in, asa man na? For internal. What about for external? Candy! Candy! If you don't know the answer, just be honest. Sure, I don't know the answer. Natulog na ko, sure. Okay, inside the cylinder, inside the engine. Okay. That is for internal, external. Okay, internal. What about for external? Combustion will take place, okay, outside the engine. Okay, next. What are examples of internal combustion? Let's have Rupert. Example of internal combustion. Give one lang.
Answer. Ah, V6 engines, sir, kana sasakyanan.
Okay. Gasoline or diesel engine. Okay. Next, what about for external? Judy. Example. Judy.
Steam engine.
Okay, steam engines. Okay. Or steam, itong ganina, steam locomotive trains. Okay. That is an example of the steam engine. Okay, thank you, Judy. Next. What are the 4 stages or strokes in a gasoline engine? Okay, let's have Jade. What are the 4 stages or strokes in a gasoline engine? 4 to siya kabuok. Iyang dimension. Itong nasa video, first video. Jade? Yes, Jade. 4 strokes in a gasoline engine. Atong mo open ang intake valve. And then next is compress. Next is the spark plug will ignite. So it pushes the piston downward. That is si tawag ato. And then last is i-release ang exhaust smokes. 4 man to kabuok. 4 stages. Okay. Need help, Jade? Call a friend? Jade? Okay, intake. First stroke is intake. Followed by, sa ito yung next. Compression. Next. Okay, combustion or power. Next. Exhaust. Okay, very good. So that is the 4 stages in a gasoline engine. Okay, gigoogle gid ni Jade. Let's proceed to our second activity, the diagram analysis. So this is the 4-stroke cycle engine. So intake, compression, combustion, and exhaust. So to fully understand the 4-stroke, let's watch this video.
A basic lesson in the fundamentals of a 4-stroke EFI gas engine may be helpful to your understanding of Mercury products. Here are the basic components of every 4-stroke gas engine: a piston, a connecting rod, a crankshaft. As the piston travels up and down in the cylinder, this lateral motion is turned into a rotating motion at the crankshaft. The longer the stroke of the piston, the larger the displacement of gas and air occurs in the cylinder. To propel that piston, we need to ignite a tiny bit of gas and a whole lot of air. This creates expansion inside the cylinder. The fuel delivery system consists of an air intake manifold, valves, intake and exhaust, a fuel injector, and a spark plug. A four-stroke engine is called a four-stroke because four up and down motions are needed to complete the cycle. In the first stroke, the piston travels downward as the intake valve opens and a mixture of air from the atmosphere and a metered amount of gas from the electronic fuel injector enter the cylinder. This is called the intake stroke. On the second stroke, the piston travels upward, compressing the air and fuel to make a highly combustible mixture. This is called the compression stroke. At this point, the spark plug fires, sending the piston downward from the expansion of the air and gas mixture. This is the combustion stroke. The fourth stroke is the exhaust stroke. As the piston travels upward, the exhaust valve opens to release the burned air-fuel mixture. When the piston reaches the top of this stroke, the intake valve opens and the cycle begins all over again. It takes one up and down motion, or two strokes of the piston, to create one revolution of the crankshaft. RPMs, or revolutions per minute, is how many times the crankshaft rotates within that minute. At wide open throttle, the crankshaft may turn at 5,000 RPMs, or a dizzyingly 83 times per second. Meanwhile, the piston traveled up and down 166 times in that same second. Want to see how fast that is? Now, that's fast. Let's see it again. Amazingly, the four-stroke EFI engine does this smoothly, quietly, and reliably for years and years of operation.
Okay, so that's the four-stroke of gasoline engine. So don't forget, intake, compression, combustion, or the power stroke, and then exhaust stroke. Okay? So any question about the internal and external combustion engine? Hello? Okay, none. Let's proceed to, okay na ni siya. Okay, third question na ta. What is the energy transformation involved in a cycle? Ito sa gasoline engine. Started from what energy? From fuel. Okay, chemical. Then next, combustion. Kato na part. Chemical. Okay, thermal or heat. And then, finally, last one. Mudagan naman dayon ang sakyanan. Okay, mechanical. So we have chemical to thermal and then mechanical. Okay. So that is why when we say heat engine, it is a device that converts heat to mechanical energy or work. Okay. Let's proceed. Madunggan ninyo ang background music. Nanay nagkaraoke. Sige lang. Okay, time check, 4:51, 9 more minutes. So just answer this exit card. Complete the following. Important thing you learned, surprised you, and then not clear about. So just answer it in our exit card Padlet. Don't mind the answers from other section. Click the link. Don't forget to write your name. I mean type. Okay, next meeting, we will proceed to laws of thermodynamics. So please study in advance. Rock you. Kindly click the raise hand button for those who are done. Okay, any question, clarification for our topic this afternoon? 9H. If none, then let's have our closing prayer.